Okay, so which equation, okay, quiet please, which equation for this, for the line contains the point -1, -2 and has a slope of -5? How do we tell what the slope of an equation is? You have to solve for y first, right? It looks like two of them are actually already solved for y, and they both have slopes of -5, right? What are you going to get if you solve this b for y? And this may be in like it seems like our answer order is mixed up between you and me, but so if I solve this one, I'm going to get y equals -5x minus 7. If I solve this one, I'm going to get y equals -5x minus 3. So what is the slope of every equation? They're all -5. So how are we going to tell which one contains the point -1, -2? You would have to plug it in. Or another thing you could do is you could just, in your calculator, put it on y equals, and then look in the table of values, which one has that point. So let's see. Try to plug in, see which one has it. I'm going to go in my order, which may be different from your order. So y equals -5 times -1 plus 3, which is 8. That's not good. Y equals -5 times -1 minus 7, which is -2. There we go. So this one right here, on yours it should have looked like 5x plus y equals -7. And, you know, I plugged it in to that, but you might have plugged it in to that. Either way, it worked. Okay, but the only way to know the slope is you got to solve for y first. So that's left over from the linear stuff we were doing yesterday. Okay, yes. Where? Because I solved it for y. If you solve that for y, you subtract 5x, you get -5x. All right, yeah. We're not doing them like one in order, right? We'll get to everything sooner or later. We got a few more days of doing this. Okay. Now, go to number 28 and 29. Right, these are simplifying square roots, simplifying cube roots, which I showed you a good way to do this in the calculator, and actually you'd probably get these answers pretty easily. You guys do that pretty well. But here's the thing, in a multiple choice format like this, you could always just like put in the calculator the square root of 675, yes? Okay. Let me check. Okay. So this is what he did, right? You put in the calculator the square root of 675, turned it into a decimal, which we don't do in class, right? What is the decimal value of that? 29 point something? 0.98. Okay, now do the same thing for these and see which one has that same value. $25.98. So this one here is 25.98. Okay, so now you put these in, right, just like they are. Which one has the same decimal value? The 15 times the square root of 3? So you find the one which has the same decimal value, and that's the answer. So you could go B. Now, let's check 29. How do you do the cubed root in the calculator? Right? You need to look at this, right? Look in your calculator. Again, this is another thing. You could take a note on this in that package and use it during the test. Where do you find cube root? Right? I'm not going to answer that question during the test since I've kind of allowed you to copy this. Let's try this. So again, if you want to find the cube root, you go math and look at the number 4 option. So I do the 1080. And I turn it into a decimal, and as a decimal, it's 10.259, right? So this one is 10.259. Okay, now put these in the calculator and do all 4 of them. Find the decimal values. The decimal values. We'll see which one is 10.259. Yeah. What'd you say? B. Okay. So it's the one place that this strategy can mess you up is they could have 2 answers which have that same decimal value. If they do, and it doesn't look like they do, but if they do, you want to pick the one that has the smallest number underneath the radical, right? So if 2 of these had the same answer, pick the one that's got the smallest number inside the radical. But other than that, if there's no variables involved, this is a way to simplify on a multiple choice test, and you would get that. Okay. So you said this is the B. So we're going to B again. 10.259. So turn them into decimals, see which one's got the same decimal answer. Simple enough, right? Okay, try the next one. Okay, so let's read. These are 21 and 22. And looks like both of them are expressions that involve absolute value. Where do you find absolute value in the calculator? Okay. Well, yeah, but you have to find the absolute value symbols first. Where's the absolute value symbols? Adam just said it. Math. Right, math, num, 1. So you need to know how to do that. There's 3 that they tell us that we're responsible for. Square root, cube root, absolute value. So we've seen them in these last 3 problems. And, calculators sometimes can help, so you need to know where it is. Again, make a note in your package. Don't ask during the test because you've had this opportunity to write it down. Now, here's where we get into the thing, which I think in this class, we actually did some of this before, which is, how do you store a value in the calculator? Okay. Okay. So let's say we wanted to say that k equals 5 in the calculator. The first thing, like Adam said, is first hit 5, right? Then hit stow, S-T-O, that's store. 5, stow, and then the k, you've got to find the k on here. Looks like it's above the parentheses, right? So you got to hit the alpha key, left parentheses, and then you have to hit enter. So it's going to look like this. So we're going to go 5, stow, alpha, left parentheses, enter. Okay, now we've got to do m equals 4 and p equals 3, right? 4, store, alpha, and this strains my eyes to see these. M is on the divide, alpha, divide, alpha, divide. That's right. And 3 store P, alpha. And where is P? On the 8, thank you. Delete, delete, alpha, 8. There we go. So everybody should have that. Store, store, store. Okay, now if you type in that expression exactly like you see it on the screen, it's going to evaluate it. It'll apply the absolute value. It'll do order of operations correctly. squaring negatives or whatever's involved, all taken care of. So try to type this in just on the main screen, not at y equals, just type in m squared minus p plus absolute value of 6 minus k times p. Right? Just type it in. I know you text all day long, right? Remind me where the m is. Divide. Okay. M squared minus alpha 8 for p plus, now I need the math num 1, and it brings up the absolute values, straight brackets, and now I've got to do 6 minus k times p. And you don't even need to do the times, you could just say kp, right? That's math num 1. Right. So where's the k? So that's right. Alpha, left parenthesis, and alpha 8. And then to get out of the absolute value, which you really don't have to, but you just right arrow. So does that look like the same thing? Yeah. M squared minus p plus 6 minus kp? Yeah. Enter. Just hit enter then. The calculator is going to do it for us. Now, you can see that this is one of these problems. It's not even a multiple choice. It's one of the free or technology enhanced items. But you can get this right. I mean, everybody should have gotten 22. Right? So that makes it pretty easy. Try to do the next one and see if you can all get, this is a multiple choice. We got to store 3 values, A, R, and P. A, R, P. So first store the values and then type in the expression. Looks like we got absolute values. Remember that sometimes we miss on this one in particular that there's actually something after the absolute value. There's a minus R. There's a minus R after the absolute value. Kind of sneaky there. What did you get? That's right.
I mean, you could type it all in. It's good practice. But
Math, type it. Num 1. Okay. What are we getting for answers? Right? How many got 24? It's 24. Syntax. Go to. So you did A store 2, not 2 store A. You did the number, store, the letter, enter. Okay. Now that kind of process works good for evaluating, and there's usually going to be a couple on the SOL that are like that. But here's where it really starts to play an important role. And now, which of the following is equivalent? So this is like operations with polynomials that honestly we don't do great with. But we can use this store a value process to actually help, because what this is saying is that that expression is the same as one of these expressions for all values of A. So if it's true for all values of A, it's got to be true for one value of A. So why don't we just give A a value, like we did on the last 2 problems, turn that into a decimal, and then see which one of those has got the same decimal value. What's that? You could. You'd have to like split it into 2 fractions. If you want to do the math of this, right? You're going to go like this. You're going to say 2a to the 5th over 2a plus 12a to the 3rd over 2a, and then simplify each fraction. And yes, that's a way to go. But again, we need to learn this store of value process because it'll actually help you with so many different kinds of problems here. Now, the question will become, on the last two problems, they gave us the value for all the letters. Here, we're kind of making this up, so we don't have a value. Well, if you're in a problem like this, what we're going to say is, if you have one variable, use pi. Store the value of pi for that one variable. Because if you choose other letters, sometimes you can, turns out, if you substitute a 0 of that expression, everything turns into zeros. But if you choose pi, that's not going to happen. So where's the pi on the calculator? Where you the exponent, the hat, or the caret? So we should store this. We only have one variable, so we're going to store pi store a enter. Okay, so let's do that. So first, second, pi store alpha a. So it should look like that, right? Pi, right arrow, a, and now you hit enter. And it'll spit back pi, right? 3.14159. We all got that memorized, right? Okay, now let's put in the calculator that expression, 2a to the, and where's the fraction format? Yeah, so make sure you use fraction format. Alpha y equals 1. Yep. Alpha y equals 1, and now I'm going to put in 2a to the 5th. 2 alpha a hat 5. Make sure that you right arrow to get out of the exponent. Plus the number 1. Sometimes it's better to do pi, believe me. 12 alpha a hat 3. Make sure to get out of the exponent. Right arrow down to alpha a. So does 2a to the 5th plus 12a to the 3rd over 2a. Make sure yours looks like that. If you look down and it turns out that actually you are still in the exponent, it doesn't look like it, you're going to have to redo it. But now when I hit enter, it's going to evaluate that expression for a equals pi. Turn it into a decimal and write it down. 156.626, I'll call it. Okay, then write that down. So, math, enter, enter. It's because you have these new calculators, right? So, 84618. And how do you do what now? So as a decimal, it's that. As a fraction, it looks like what? Is that an 8? I can hardly read that. What does the fraction say? Yeah, read me the fraction. Is that 946? 946. That first one I couldn't read. 182 over 6041. Okay, put these 4 in the calculator. Now put these in there one at a time. See which one has the same value. How do you what? The value? Just restore a different value over the top of it. Yeah. Yes. You can do this. You can do this with the math. This is another option that'll actually end up working for many other kinds of problems too. Which one of those has the same value? Which one? Your B is what? Read it. Is it this one? Yeah, for mine it's D. So a to the fourth plus 6a squared. So the answer should have been this expression right there. I think for you guys it's B. For me it was a D. Okay. Okay, try to do the same thing on this one. Another operations with polynomials. Store a value for y. What value are you going to store? Pi. Right? Then put that expression in, turn it into a decimal or a fraction, and see which one is the same value. So pi store. So what do you get when you just found the decimal value of the original? 6.14?
Yeah.
Okay. So now which one of those has that same value? So is it the one that says y plus 3?
Yeah.
So it's the one that says y plus 3. Yeah. Okay, quiet please. Callie's saying something. Slide and divide thing? Yeah. Okay. 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 And did you FOIL it then to make sure it worked? I mean, that's something you could do. I mean, he's saying, look, if the numerator divided by the denominator is that thing, then it's going to have to be that, negative 15 divided by negative 5 has got to be that positive 3. And the 2y squared divided by 2y would have just given you the y. That essentially is correct. Okay, let's look at another one. Okay, now what do you notice about this? Yeah. Okay, how many variables are there? There's actually 3 variables. So here's the thing is, if you're going to use this method of storing values, you don't want to use the same value for all the variables. Okay, so what you should use for the first variable is pi. For the second variable, pi plus 1. For the third variable, pi plus 2. That makes them irrational numbers that are not likely to cause any kind of cancellations or anything like that. So in this case, what are our variables? X, y, and w. So again, let's let x equal pi. Y can equal pi plus 1. And w can be pi plus 2. Just give them different values. So second, pi, stow, x. Okay, so this is what it looks like when you store y equals pi plus 1, right? First you're going to go second pi, and then you put +1, and then you do the store. Right? See how it looks? Pi +1, store, y. And when you hit enter, it'll spit back the decimal value. Right? And now we'll try it one more time for W. Which key is a W? The negative. Right? So let's go. Second pi +2. So, and now we're going to go, what we just say? It's not minus alpha minus. Okay, now we're going to have to type in this complete expression. Like this is a properties of exponents problem. Just type it in exactly like you see it. You know, where they've got parentheses, you need parentheses.
Wait, how'd you actually solve it?
How would you actually do it? Well, first, they put parentheses there, which are not really necessary, but you would multiply the numerator, right? And then you'd have to use properties of exponents, right? What's x times 24x squared y to the third w? Well, it's not a distribute, right? Because there's no plus or minus, but that x times x squared is going to give you how many x's? X to the third. That y times y to the third is going to give you how many y's for us? And then you're going to have to simplify 24 over 36. Then we said x to the third. It's only x. It's the only x term. How about y to the fourth over y to the fifth? I mean, just use properties of exponents. You know. Did anybody get a decimal value for that beast?
Yeah.
What was it? 0.97. So this thing is like 0.97. So which one of these has that same value? Anybody? Which one had that same value? D on mine. So you put this one in, and you also got 0.97? Okay. Yes. Go to. You don't have the store in there. You don't have that right arrow, right? Okay. So I mean, this kind of method, all the different kinds of operations with polynomials, add, subtract, multiply that we did, all the properties of exponent problems, generally this method will work. The same method will work for all of them. Most of the time in any question where they use the word equivalent, that means that you could use the store of value and get that problem right. Now, if you know the math, all the better, and it's probably a lot quicker to do it that way. But if you don't know how to do it, you're struggling with the math, this is the way to get it right. Now, this is a concept that we haven't talked about, but I saw that it is something that's going to come up. A prime, what is a prime number?
Well, you can't multiply it.
A number that doesn't have any factors except for itself and 1. Okay, a prime polynomial doesn't have any factors. There's no common factors. So look at those 4 right there and tell me which one has no common factors between the two terms. On your page, well, in my C, they both have a Y. So there is a common factor. Okay? It's on mine, it's the A. 5xy and minus 2. There's no common factors. 2. They both have a 2. 4 is divisible by 2. But there is something you could factor from both terms. That's 2. So this concept of prime polynomial, we're supposed to know that. Okay, last one. So here's another one, simplifying radicals, right? Simplifying a radical, you could do the store of value. I mean, we had this a couple tests ago. Remember, we would first have to find the square root of 112 without turning it into a decimal, because the answers never have decimals in them. And then you'd have, how many x's can you take out of it? If it's x, the square root of x to the 6th, how many x's come out? Remember, you go 6 divided by 2 is 3, right? Can you take out all of the y's? No, because 3 doesn't divide by 2. So you split it up into y squared times y. And then the square root of y squared is y, right? So anyways, those are the math rules for doing this. But you could also store values. So let's try that. X, y, and z, and then we'll see which one of these is correct. Do it quickly, right? So we already stored x equals pi. I think we have already stored y, didn't we? Alpha 1, alpha 1. Yep, that's already in there. So we just have to store the z. So let's go. Second pi plus 2 store alpha z. Which key is a z? 2? And then you just have to put in this second square root. Just type it exactly like you see it. 112 x to the 6th. X hat 6. Get out of the exponent. Alpha 1 hat 3. Get out of the exponent. Alpha z hat 5. And I'm not sure why mine, somehow I didn't get the z stored. Okay. So I mean, when I turn this into a decimal, I'm getting 165,788. $296, right? And then if you do the same thing now, I think in the end this one's going to end up being 4. I think it ends up being this one right here. Okay. So this storing a value thing is going to, in the end, it'll solve so many problems for you on this test coming up and on the SOL. So we really want to get good at this. And you can fight it for a while, but when we get up to the SOL, we'll be kind of serious about let's get these things all right. So that's the homework. Come back and do a little more fun and games.